Okay, so you have completed 2 of the simulations on the Proteus on the stepper motor. Okay, the stepper motor that you have over there is 90-degree step angle. In the Proteus design, it will be only using 90-degree step angle. Alright, so that's only for the learning purposes. But the real world is, normally your stepper motor does not 90 degree per step because it's maybe smaller than that. So the resolution is smaller. So you can control your angle is much precise. Okay, you can control better than the servo motor. You can control better than DC motor. You cannot control the angle on DC motor. But your stepper motor, you can directly control the angle. Okay, let's look at the results from here. The first one that I have is basically on the wave drive. From the code that I gave you, the first one is the wave drive, and the second one is the full drive. Over here in the code, we are still using the PWM drive over here, because that you are using L293D. Okay, but my simulation Proteus, I do not connect my CCP pins to the enable pin over here. By right, you can just simply take the CCP pins that you drive to enable 1 and enable 2. This example, I directly connect it to 5 volt. 5 volt means 5 volt. You drive high. Your code says you drive 255, means you also drive high, right? That's the PWM, average voltage is 5 volt. So it's the same thing. When you look at the code, you are playing with the PWM. Because you are using the L293D. For my purpose of this one, I just connect this one to the one. You also can connect these 2 enable pins directly to the CCP pins right over there. It's the same thing. No problem because it's driving 5 volt. Alright? This example shows that on the first one, on the full drive, although the wave drive, call it wave drive here. Okay, let's try the wave drive first. 0, this is 0, this is 0, okay, sorry, this is 0, right? Okay, I compile this one first. So look at the results here. I drive it 1 by 1. So they call it a wave drive. You can see that the red color is coming here, then let's go here, let's go here, let's go here, same like your coding. And your CCP pins in the PWM, you drive it 255, you can see that your CCP pins over here consistently red in color, which is 5 volt. Consistently, if you measure up, it's also 5 volt. So it means that I also enable these 2 enable pins, I directly connect to 5 volt. It's the same thing. I keep on repeating, it's the same thing. You can simply just connect this guy to this guy. It's the same thing. You are driving the driver motor correctly. So you can see that this is also high, this is also high. And this is connected to the 5 volt over here. You can also simply take these 2 pins without using this one, connect to the CCP pins that you drive, because that pins is also 5 volt. Alright? You are driving 255. Remember that DC, you can drive from 0 to 255. That's the level of the voltage. For 5 volt is 255, 0 volt is 0. If you are playing with 2.5 means 255 divided by 2 is the half of the 255. Okay, so far? Understand? So right now you can see that how the motor is moving, stepping correctly. So it steps over here, the direction is over here like this. I never tried direction, the reverse one. I never tried, but you can try today. I don't know what happened today. If you drive this one in reverse, what happened? Have you tried before? Let's say for example here, this is driving here from top to bottom, right? So right now you can try to drive from the bottom to top. What happened to the stepping over here? So right now now you can see that the stepping for this particular example, every time it steps, it will be the step angle is 90 degree, correct? But the starting point is around negative 135, 225, and then go back to 45, 135, 225, 315, and 45 again. Keep on repeating it. So let's try reverse it. I never tried reverse it. So let's look at the example. Let's try to reverse what happened. Instead of like this, I want to drive like this. 1, 0, 1, 0. Wow, it's different, right? The driving is in another direction, right? So this is my first time I reverse it. But it shows that, prove that you can control the direction of the stepper motor by triggering back to the other direction. The stepper motor you can drive back. Instead of one direction, you can control another direction by triggering on the reverse position. Agree? Proteus say okay, no problem. It's still stepping at 90 degrees, so I change back to full weight drive. Let's look at the full weight drive. Full weight drive is this one, 1, 1. This is 0. This is 1. This is 1, 0. This is 1, 0. This is 1. This is 1. And that is 1. So the drive is like this. And your front gears will see what? For the full-weight drive, the positions of the stepper motor is starting around 0 to 90 degree. Just now it's 45 degree, correct? Huh? So this is the directions over here. So it's still stepping around 90 degree, but the starting point is different. That's all. You can drive the same thing, but it gives you the same result. Okay, do you guys understand, huh? What's the difference? That's how the difference is only how to control it. That's all.
I mean, if you add more angles, like 45 instead of 90, will it be?
That why it depends on the. That's why when you purchase the stepper motor, you need to know what's the stepping angle that it can step. For example, here just now the full weight drive and step is the same every time step angle, right? So it's the same thing for if you drive another stepper motor which is having different step angle. It's only one step per step. Per step.
Do you want to have different step?
Yeah, the step is the same. The step angle is still the same. You can every time you do the stepping, but the method to drive is a bit different. That's all.
Previously, you said your motor is
For example, yes.
but you are still using like what from which?
This one battery 5 volt, 12 volt.
No, you said we can use 5 volt.
This one.
Yes.
This one or this one?
You said you can use from inside the
Okay, someone asked about this one. Maybe you guys confused. Confused, that doesn't matter. So somebody asked, why I'm still using this one, right? Is this that? Okay, the thing is, why do you need to use driver? The driver, if you L29 3D, there will be a point over here to connect to the battery over here. Okay? So basically, when you purchase a motor, the motor will tell you the voltage rated. If it is moving at 5 volt, so you may not require to connect to this guy. May not require. But for example, your motor is 24 volts. It's very hard. It's a big motor. Right? So you still require me to have this driver. Because you cannot drive 5 volts here and drive the motor. The motor does not move it because it requires up to 24 volts. So it means that you have to connect 24 volts over here. This battery is giving you the power to the motor. This one is not giving the power. This one is giving you the PWM, which is the highest one is 5 volt. For example, in DC motor, the PWM requires for you to test and to change the speed, correct or not? So this PWM will control the speed of the motor. But the motor requires up to 24 volt. The speed must be controlled by the CCP pins and PWM. Understand? That's the difference. Your motor requires 24 volts. That is the requirement. If you put 24 volts, you will have the full direction 24 volts, right? Something like that. Put 24 volts. That is external battery. But over here, the driver requires you to give PWM, so your PIC can generate that one, and this PWM can control the speed of the motor, provided you are giving external battery over here. That's why it has to use the driver. Okay? Okay, let's Suhail. Suhail? Okay? So any question? Any question from this one? Stepper motor easy? Easy to understand? Huh? Alright, so this one. So back to the thing. I taught you guys 3 motors. Anyway, I keep on repeating this. I taught you guys 3 motors. How to control it, the difference on it, and how it works. So you can see that if you put a table over here to these 3 motors, you can know that the differences on each of them. You cannot just simply drive like that because you have to know how to drive it accordingly to the microcontroller. Okay? So that's all for this one before I proceed to the other one. Is it okay everything? So the code is there. So the book I have to fix now. So open up the stepper motor.